Problem 157, Classical Mechanics. The question is, an annulus of mass m made of a material of uniform density has inner and outer radii a and b respectively. Its principal moment of inertia along the axis of symmetry perpendicular to the plane of the annulus is. In the present problem, an annular disk is given. We have to find out the principal moment of inertia along the axis of symmetry. Here the annular disk has the inner radius A and outer radius B. Assume that the annular disk is made up of large number of concentric rings. Now consider a ring of radius x and thickness dx. So in the annular disk you consider a ring of radius x and thickness dx. Here A is the inner radius and B is the outer radius of the disk. Now area of the given area of the ring we have taken, that is 2 pi x dx. Now what is the mass of that ring? That is 2 pi x dx into mass per unit area. Since sigma is the mass per unit area, mass is equal to sigma into area. Therefore, the mass of the ring is sigma into area of the ring, that is sigma into 2 pi x dx. Now, what is the moment of inertia of this ring about the axis PQ? Now, the moment of inertia of the ring about the axis PQ is equal to sigma 2 pi x dx into x square, because moment of inertia is mr square. Therefore, mass is sigma 2 pi x dx and the distance is x from the axis. Therefore, the moment of inertia of the ring about the axis PQ is 2 pi x cube, then sigma dx. Now we have to find out the moment of inertia about the annular disk about the same axis PQ. We have the moment of inertia of the ring about the same axis PQ is 2 pi x cube sigma dx. Now the disk is made up of several such rings with the radius varying from A to B. Therefore, moment of inertia of the annular disk about the same axis PQ is integral A to B sigma 2 pi x cube dx, that is 2 pi sigma x raised to 4 by 4 from the limit A to B, and that is equal to pi sigma by 2 into b raised to 4 minus a raised to 4. That is the moment of inertia of the annular disk about the axis PQ is pi sigma by 2 into b square plus a square into b square minus a square. Now we have the mass of the annular disk m is equal to pi sigma into b square minus a square. Therefore, the moment of inertia of the annular disk is m by 2 into b square plus a square. Therefore, option D is correct.